What's up, Codervite? Welcome back to another data structures and algorithms video. I'm Elizabeth, and today we are going to be continuing to talk all about dynamic arrays. Today's problem is a pretty popular one. I think that you'll find it in a lot of practice books like Cracking the Coding Interview or something like that, or online. But that doesn't mean that I think it's less useful. In fact, I think it's more useful to really understand the foundations and the concepts behind this problem. So let's get into it. The problem. Liz wants everyone at her company to all hang out for a game of Minecraft, but everyone has told her that they have too many meetings. This is a real world problem, P.S. She knows that there must be some time throughout the day that they are all free to spend some quality time with each other. Write a function that, given an array of everyone's meetings, returns a list of merged meetings so that Liz can see when everyone is free for games. Okay, so this is obviously this array of meetings, right? And what we really need to find out is what format are we getting these meetings in, and how can we merge them in such a way that we can figure out when everyone has meetings versus when everyone is free, right? So if we have ranges, right? Let's say a range where I have a meeting from 2 p.m. to 4 p.m. and my coworker has a meeting from 1 p.m. to 3 p.m., that range becomes 1 p.m. to 4 p.m., right? Where we are both busy, that is not a valid time for either of us to be playing games versus some other time of the day when both of us do not have meetings. So here are some examples of some inputs we're going to get to this function. So here we have a meetings array, const meetings, right? And we have some start times and some end times. Now you'll see here that these are all integers, right? And in the comments over here, I've put in what those integers are actually denoting, what they refer to, right? So here we have a start time of 4 and an end time of 8. What does that mean? It's 11 a.m. to 1 p.m. So what are the integers and how do they map to the times? That's number one. So here the meetings are represented by blocks of 30 minutes. So when I say 4, what I really mean is it's 4 blocks of 30 minutes past 9 a.m. So 4 blocks of 30 minutes past 9 a.m., you can start by saying, right, 9 to 9:30 is the first block, 9:30 to 10 is the second block, 10 to 10:30 is the third block, and then finally 10:30 to 11 is that fourth block, and that's how I got to the 11 a.m. This is very similar to how any sort of like Unix timestamps work, right? Where you're getting a number of seconds past a certain time and date that we've all agreed upon so that we can then compare times using integer values instead of these, what are really just arbitrary values that we know or more commonly use when we're referring to times throughout the day when we're talking to other human beings. So that's the first thing to understand here. Exactly how the meetings are going to be structured and what those time blocks are going to be represented by. And I think the second thing to really talk about here is, okay, so if we get this array of meetings, how can we decide or how can we understand the overlaps, right? So if this meeting starts at 11 a.m. and ends at 1 p.m., it overlaps with this other meeting that starts at 10:30 and ends at 11:30, right? That means nobody is free from the time of 10:30 a.m. to 1 p.m., right? Because these meetings overlap. So if one or two people aren't free, the whole team is not free for games. So let's look at what this might look like if we merge these together. So what we have here is we have one meeting, right, that starts at 0, which is 9 a.m., and it ends at 9:30 a.m. So that's this one right here, right? So someone has this meeting and no one else has that meeting, but because someone has that meeting, we can't play Minecraft during that block, right? The next block that takes place is from 3 to 8. So the way we did that, right, is we saw this start time, right? This starts at 3 or 10:30 a.m. And then there are overlaps all the way until 8, right, which is 1 p.m. here. Because again, this person starts at 10:30, right? And despite the fact that this person is free after 11:30, there's someone else who has a meeting, which is starting at 11 to 1. So really, nobody is free from 10:30 to 1, right? Because there's an overlap in those ranges. So we have to find the times that there are nobody has any meetings. So I hope that's clear exactly how we're doing this. And we're basically, you know, the first thing I think of when I think of this sort of problem is this is going to be some sort of reduction, right? We're taking one large array and we're somehow reducing it down to based on a certain set of rules that we're defining. We're reducing it to a smaller range such that we can determine the times between, right? We're looking for when is everybody free? When does nobody have a meeting? So how might we do this intuitively? Again, I think a wonderful way to try and solve any coding problem is to first ask yourself, if I had to do this with just my brain, without code, without pencil and paper, whatever, how would I solve this intuitively? And then work from there, because often what you don't realize you're doing intuitively are the building blocks to your algorithm. So here's our approach. Let's take our meetings. So this is our first, use case, right? We have a bunch of different meetings that we've gotten. These are everybody's meetings in the day. The first thing we might want to do is sort them, right? Because after we sort them, we can then determine we can take the earliest time that somebody has a meeting and then extend that range to the end of whoever else's meetings start in that range, right? Even if the person whose meeting starts the soonest ends somewhere in the middle of that range. So the first thing we want to do, right? So this is just, again, where we're going. And often it's very useful to kind of take a test case, look at what the answer is for that test case, and then work backwards. So you can see here that it's sorted, right? Because intuitively, we want to know when do the meetings start and then when do they end. So here is our sorted meetings, right? So I've now sorted them by start time. So let's say I have a meeting that starts at 9 to 9:30. Someone else has a meeting that starts from 10:30 to 11:30. Okay, so no one has any meetings between 9:30 and 10:30, right? So we can take that first meeting and just add it to our array over here, right? Okay, so now we know that we are free from this 1 to 3 block, aka the 9:30 to 10:30 block, right? Okay, so our next meeting starts at 10:30 and it ends at 11:30, which overlaps with this person's meeting, right? This person's meeting starts at 11 and it ends at 1, right? Okay, this person's meeting starts at 1:30. So we're again at a place where we have some time between. So that means we can merge these two, right? So we can take the start time of the earlier meeting, and then we can take the end time of the later meeting, right? Whichever end time is later. So in this case, if this first meeting ended, let's say at 1:30 or 1:15, right? It wouldn't in this case because these are blocks of 30 minutes. But if it ended at 1:15, we would entirely just slurp up that second meeting because it doesn't matter. We're taking a range, right? So I want that to be clear here that what we're doing is we're not just taking the start time of the first meeting and the end time of the second meeting. We're taking the start time of the first meeting and we are taking the maximum end time of either of the two meetings that we're looking at, right? So in this case, that happens to be the second meeting at number 8, right? So we then take that and we can add it to our array. And then we continue. So then we have a start time of 9. So again, we found a little bit of a block where we can potentially play Minecraft. Excellent. And that would be between 1 and 1:30. But we have another meeting starting at 1:30. This one ends at 2 p.m. And then we have another meeting that starts at 2 p.m. and ends at 3 p.m. So in this case, again, we would take the start time of that first meeting, which is 9, and we would take the max of the two meetings that we're comparing, which would be the second one, which is 12. So we have another condensed range, which starts at 9 and ends at 12, or 1:30 p.m. to 3 p.m. So that's the approach. To reiterate, the first thing we're going to do is we are going to sort the meetings by start time. So this is, again, so that we can compare things, right? So that when we're building our ranges, we always know that we've seen all of the meetings that start before whatever meeting we're currently at, right? The second step will be to begin with the first meeting, obviously. And we want to look at every next meeting greedily, right? And why greedily? This is a greedy algorithm. The thing that makes this greedy is that we take the next best answer and we use that as our answer until it's no longer the next best answer, right? So like I said, here we take the first meeting and we add it to our merged meetings until we get one where the end time is later. We take the max of the two meetings we're comparing, and then we take the max of that, and then we compare that to the next meeting, right? And we take the max again. So we take the best answer we have and we continue the iteration, taking the next best answer with each iteration until we have the best answer and we have the entire completed merged meetings array. So that's what we mean by greedily here. Now, once we take the next meeting, we can ask ourselves two things, right? If the start time of the next meeting is greater than the start time of the previous meeting, we can merge them, right? If not, don't worry about it. We found a range, and that is a good range. We can start a new merged meeting with the next start time, right? Set the new end time to be the later end time or the max end time of the two meetings. So the next merged meeting is going to be the later of the two end times of the two meetings we're comparing. And again, this is greedy, right? This is going to be our answer until we have another meeting that will displace the previous answer that we've already come to, or that is the merged meeting and we're going to start a new range. So I hope that's clear to everybody. I think this is going to be much clearer when we code this out, which is surprising, but I love that when the code actually fulfills a purpose and can explain what's happening intuitively. Yeah, I think this is a great problem because functionally it's not very difficult, right? These are very easy operations. It's a loop, it's comparing things, but intuitively you have to understand what's actually happening in order to make these ranges. So let's get into it. You guys know the drill by now. As per usual, I have just filled in my Visual Studio Code editor some test cases for us to test against. So you'll see here that I have the same exact list of meetings that we had in the slides and what the expected output should be. And then I have a few others. I have one where two meetings are kind of back to back to each other, where we would expect that the merged meetings would be the beginning of the first one and the end of the second one. And then I have two where there's one meeting that kind of it envelops the other meetings, right? So here someone has a meeting from 1 to 5, long meeting, I'm not envious of them. And that kind of swallows up this other meeting, which is in the middle of that, which is 2 and 3. And we just get that first meeting, which is 1 and 5. And the same with this one, which I really don't envy. This person has a meeting from 1 to 10, right? And the rest of them are inside that 1 to 10 range. But we can just return the 1 to 10 as all of the time that someone is unavailable for games. Okay, so to get us started, let's start up here. We're going to start with a function, right? Function merge meetings. And this is just going to take an array, right? So this is going to take an array of meetings. So why don't we call it just meetings? And the first thing we want to do, right, is sort the meetings. And the sorting fulfills a purpose. That purpose is that while we're looking at the meetings in sequence, we always know that we're looking at the meeting. The first meeting we're looking at is the meeting with the earliest start time, right? So in JavaScript, we can just pass in a callback to the sort function, right? And the sort function will take two different, right? It's going to take the two different elements it's comparing. And the rules are essentially, if the function returns a -1, the first element it was looking at, or a negative number at all, right? The first element it's looking at needs to come earlier in the array. And if it is greater than 0, right, 1 or above, whatever, then the second element has to come first. And if it's 0, they're equal, you can just add them in according to the order that you saw them in. So let's write that here. Let's say const sorted meetings. equals meetings dot sort. And then here is our callback. So we'll get the first meeting and the second meeting, right? And we can just make that a nice little arrow function. And we can just return the meeting one, right? Dot start time, because we're sorting by start time, is minus the second meeting start time, right? And what that will do is that will, right, if this value is smaller than this value, a smaller number minus a bigger number will be a negative number, right? And that means that this should come first, right? This first meeting. If it's a bigger number than this number, then it will be positive, and that means that it should come second in the sorted order, etc. So that's, pretty standard, a good thing to know how that works because it's useful. But that's basically just how we're going to sort our meetings to look through. Okay, so again, like I said in the slides, I think this is a great opportunity to use a reduce function, because what we're doing is we're going over the meetings and we're basically reducing into an accumulator, right? And the accumulator would be, in our case, a merged meetings array, but also we're kind of accumulating all the meetings in a certain range until we end the range. So I think a reduce is an awesome use case for reduce. Reduce is one of those functions that actually it took me a really long time to really understand what was happening in a reduce function. But once you get it, it's a very useful tool. And I think it's a way to kind of demonstrate some mastery over JavaScript and, whatever to your interviewer. So just food for thought. Although you could definitely do a loop here, any kind of for loop. I'm going to use a reduce just because I like it. So I think we can just return whatever we reduce, right? Because whatever we're accumulating, that's going to be our merged meetings array. So I'm going to say return, and then we're going to go over these sorted meetings, right? And we are going to sort the sorted meetings.reduce, right? And what we're going to reduce here, right? What a reduce function takes is it takes a callback function, which is going to be whatever the accumulator is, and then the next element, right? So what is the accumulator? The accumulator in this case would just be an array. And this is going to be our merged meetings array, right? This is the thing that we are going to create out of the sorted meetings array. So this right here is going to be that merged meetings, right? This is another word for accumulator. You might see in a reduce function that people use ACC for accumulator or previous, right? Because the thing that you're getting is the return of the previous iteration. But it's also just that it's the thing that you're kind of building as you reduce. So I'm going to call it merged meetings because in my mind, that's what we're reducing. That's what we're ultimately returning here. So we're getting the merged meetings as our first argument. And as our second argument, we're going to say it's the next meeting, right? So this is going to be not from here, right? Not from whatever the accumulator is. This is going to be what's coming out of those sorted meetings. This is the next element in the iteration. So that's what we have here thus far. Here, let's make our arrow function. And we have our reduce. So what do we want to do here, right? We want to take that first meeting and we want to add it to our merged meetings, this array, right? So how do we do that initially? So what I'm going to do is I'm going to take, right? I'm going to take whatever is the last thing that is in this merged meetings, right? Which is basically going to be whatever the last iteration has returned. And you'll see in a second, because of course, at the onset, there will be nothing there. So you'll see how we initialize this. But let's say that we're in the middle of our iteration. We want to be comparing the next thing to whatever the previous range is that we've started. So how I'm going to do that, I think, is I'm going to say, whatever that merged meetings is, I'm going to slice it, -1, right? So that's just going to basically create an array of the last element of the merged meetings array, right? And what we can do here is we can use this destructuring, which we got with ES6, right? And we can call that element, that's last element in the merged meetings array, we can call it the previous meeting, right? This is the last meeting that we've kind of greedily created. And then we can refer to the previous meeting rather than referring to this array of one. So that's kind of like a cool thing, right? But again, this is not going to be anything at first because merged meetings is an empty array. So what do we do in that case? So we can say that if there's no previous meeting, right? So this is, again, this is the first iteration of this reduce, iteration of reduce init step, right? This is when we're initializing that the first range that we're starting with. We can push into that merged meetings array. I'm already seeing that I wonder if I'm going to have errors because I wrote merged meetings instead of merged meetings, but we'll get to that. I don't see any issues yet, but that's for sure going to be something I do by accident. So if there's nothing there yet, we want to push there, right? We can push a new kind of, this is going to be our first greedy gobbling up of a range, right? So we can say that we can push a meeting with a start time of the next meeting dot start time, right? And an end time also of the next meeting dot end time. And so what that will do here is if there's nothing yet, we just initialize it with whatever comes first. So let's take an example here. So this is not sorted yet, but let's imagine that it is. This would be our first meeting, right? So there's nothing in our merge meeting yet. So we can take this and start with it, right? We're going to say this is going to be the previous meeting that we are then modifying and updating, right? In our next iteration. So that's all there is to the init step, right? And then the rest of it is really relatively simple, right? So if there is a previous meeting, which means that we are now comparing whatever the previous meeting is in our merged meetings, right? Merged meetings array to the next meeting in our sorted meetings array. So this is how we continue to greedily gobble up things into our ranges, right? We're not actually only comparing meeting to meeting. We're comparing whatever we're accumulating to the next meeting, the next meeting, the next meeting. This is how, in let's say this case, right, down here, we might start with 1 and 10, right? And then we get to this one. We're comparing 1 and 10 to this one. Oh, it's gobbled up. Okay, then we get to this one. Oh, it's gobbled up. Okay, right? We're not actually comparing necessarily the things in the merged meetings to each other. What we want to do is compare everything that comes after our merged meetings to whatever's in those sorted meetings. So let's look, for example, here. So what happens if we already have a previous meeting? So what did we say? If the next meeting, right, if the next meeting has a start time that is greater, right, than the previous meeting's end time, right, that means we're done with that range and we can actually start a new range, right? So in that case, we would just, right, this is the easy case, we would just push that merge into the merged meetings. We'd push the next meeting because we're ready to start a new range, right? Because this is, right, if the next meeting's end time, start time, excuse me, is greater than the previous meeting's end time, then we've completed a range already. It's sorted. We know that. We can then just add this one as the next one, and this will be the next range that we begin to kind of, slurp other data into. But what if that's not the case, right? What if the next meeting's start time is less than the previous meeting's end time? That means that it's in the range, right? So we need to merge the two. So this is the meat of this algorithm, right? So what do we want to check here? We want to check here that if the next meeting's, right, start time is less than or equal, right? Because even if it's equal, we want to merge them. The previous meeting's start time, or excuse me, the previous meeting's end time, right? It's in that range, right? So what do we want to do? At this point, we want to check. We know they overlap, but whose end time do we choose for that previous meeting, right? We want to take the maximum, the one, whoever's meeting, the first one or the second one, whoever has the later meeting end time, right? That's going to be the end of the previous, the range that we're now accumulating. So here we can just set, right, the previous meeting's end time to be the max, right? And this is where we compare the two of the previous meeting's end time or the current meeting, right? The next meeting's end time. Whichever one is actually greater, that's the one we want, right? And we only, right, we wrote this in advance, but we only want to do this. Yep. We only want to do this, right, if this next meeting start time is greater than the previous meeting's end time. We don't want to do both, we want to do either. So we wrote this first because this was the easier case that I wanted to write, but this is actually an if else. We want to do one or the other, right? And this is just, that's the whole algorithm, right? Essentially, we have one thing, and then we continue to move throughout this sorted meetings array until we are at the end and we've made all these ranges. So the last thing we have to do in a reduce is we want to return the accumulator, right? We want to return the thing that we're accumulating so that the next iteration has access to whatever we've done in this iteration. So here that's pretty simple. We just want to return those merged meetings. And before we walk through this, let's make sure it works. So let's look at our test cases here. And let's say node merge meetings. Okay, so here's our first one, right? So that is correctly slurped. I keep saying that, and I can't think of a better word. That's why I keep saying it. And then we have our other meetings that are kind of getting all together, right? Like 1 and 5 totally envelops the meeting that starts at 2 and ends at 3. So that is, oh no, that's the wrong one. This one starts at 1 and 2, right? Start time 1 ends at 2. This one starts at 2, ends at 3. So we want to range from 1 to 3, and we get that. Here, 1 and 5 totally envelops 2 and 3. That's exactly what we wanted right here. And then finally at the end, we have 1 and 10, which is right here. So let's make some, I want to console log some stuff out so that you guys, again, see what's happening in each step here. So I think what we want to log out is, let's see, console.log, we're going to say prev meeting. And I want console.log next meeting. And then here, I think that's maybe all I want, right? Let's console log out this merged meetings. And let's not call each of these because I don't want there to be so many logs in the console. Okay, so we're back with our original example, and let's see what we get here. Ah, excellent. That's exactly what I wanted to show you all. Okay, so how can we do this? So this is basically we're just logging out that these are objects, right? So something you can do to log out any objects, right? So what's happening is we're interpolating this into a string. So of course, if we went console log prev meeting, I believe that will log out the actual object, right? There's that log. The reason why I did it like this with these backticks is because I wanted to label each of these without having to make 2 different console log steps, right? So of course, if I actually wanted to just do that, I could do two different console log steps. And here I would do console.log previous meeting, and then I would actually log out the thing, right? So that would be all nice and dandy. Another thing you could do though, right, and this is a cool trick that I think someone at some company told me way in the beginning of my career and I use often, is you can JSON stringify, right? So we can just stringify this object, and if we want to have it printed in a pretty way, right, we don't want the object just all on one line, you can do json.stringify previous meeting, and then what you do is as the two other parameters that you pass, which one is indentation and one is spaces, something like that, I don't know, someone look this up and write it in the comments, but you can just do null and 2, and let's see if I get that right here, that yes, so this, now we have this nice log and we have everything pretty printed, right, with all on the right lines with all the right spaces. So just a trick, you know, in case anyone cares. But it's basically just a way of, it's a nice way of logging JSON or objects or whatever. And you can do it in this kind of interpolation, right? Okay, so let's try again. And let's clear this all out. Nope. Okay, so let's start. Okay, so the first iteration, the previous meeting is undefined, exactly as we would expect. And this next meeting is the first meeting, right? So that's 0 and 1 because we've sorted, right? So that is this one, right? So the first thing that happens is we just push that, right? We push that, we initialize into our merge meetings, we push the next meeting, right? And here we're already at our next iteration. So here we have our previous meeting, right? So that's with the start time of 0 and 1, which is what we would expect, right? And then our next meeting is 3 and 5, right? So here's our next meeting at 3 and 5. Now, we want to push that as well, right? Because the next meeting start time is not less than or equal to previous meeting's end time, right? So we then see that, we push that to our merged meetings here, right? And now we have 2. We have 0 and 1, and we have 3 and 5. Now this one is forever untouched because we don't need to worry about it anymore because we've sorted these meetings in advance and we know that this is the only one that's ever going to really matter. Anything in the future is going to have ranges that overlap with this one or not, right? And then we move on. So in our next iteration, this is now the new previous, right? We have 3 and 5, and the next meeting is 4 and 8. Okay, great. Finally, we have one where the start time is less than, right? The start time of the next meeting, which is this one, is less than the previous meeting's end time. So we have an overlap, right? So what do? We take the max of between the previous meeting's end time and the next meeting's end time. So in this case, it's the next meeting's end time, right? That's 8. So we then modify in place, right, the previous meeting's end time. So, and this is the slurping. This is, again, sorry guys. This is the way that we're kind of creating these ranges in place. We take the next best answer and we modify what we've already had. In the last iteration, the next best answer was not 3, 8. It was, 3, 5, right? That was the range. But now we know we have one more piece of information. We can then update that previous meeting in place, right? And that becomes the new end time. So now our previous meeting is 3 and 8. And again, I want to emphasize that the meeting that we're comparing to is not the previous meeting in the sorted meetings array. This is the previous meeting in the accumulator, right? This is the thing, we're comparing it to the last thing we pushed to our merged meetings array. So I just want to emphasize that. So we have our previous meeting, right? So this is starting at 3, ending at 8, and our next meeting, which is 9 and 10. So none of that is true, right? So our next meeting's end time is actually greater than our previous meeting's end time, so we can just push that, right? So we get a third entry in our merged meetings list, right? And finally, again, we have our previous meeting is 9 and 10, right? Starting at 9, ending at 10. Our next meeting is 10, ending at 12. So we have the less than or equal to, it's equal to, right? So we end up in this line right here, and we take the max end time, which is 12, right? So we push 9 and 12, or we modify, right? We put 12 instead of whatever we had there, which was 10 before, right? So we modify in place, and we're at the end, right? So we just return the accumulator, and that's this right here, which is the same as you can see right here. So I hope that was helpful to kind of walk through what's happening. Again, I think a lot of people solve this with just a for loop, but I think a reduce is an excellent opportunity. It's like an excellent opportunity for a reduce, because in my mind, what we're doing is we are literally reducing, right? We are reducing one array into something that is a condensed version of that same array. So leave it in the comments if you have other solutions to this. In terms of big O, the things you have to take into account here is that you have to take into account the cost of sorting, right? So in this case, because we have our own sorting function, I believe this would just be a big O of n, because we have to go through every single meeting at least once to make this determination. I think if you just did the sort, right, the vanilla JavaScript sort with integers or, I don't know, strings or whatever, that would be maybe n log n. I'm not totally sure about that, but because we're passing in our own function here, it has to go through each one to make the check. And then the reduce is the same, right? We're reducing over that sorted meetings. So that's a big O of n. So 2 n's, you can drop it. It's just a big O of n. And in terms of space, we're creating this, merged meeting. We're creating this sorted meetings. So that's big O of n, which I would say envelops this merged meetings, right? So we're at least making one copy that's the same size of the original meetings array. So yeah, that's it. I think this is, again, a really, really good opportunity to practice those foundational skills. The logic here is very simple. It's nothing more than comparing and looping, but to really understand what's happening and to be able to apply this in other ways, I think is really valuable. Thanks for joining me for another awesome dynamic arrays video. I'm super excited about this series, mostly because I think these videos are touching on some of the really foundational skills that it's important to demonstrate to your interviewer that you understand inside and out. Join me next week. We'll do another one of these. I don't know how many more we'll do. Let me know if this is something you're super interested in. Otherwise, we'll start a new series on one of the other million topics that I'm sure you're all trying to master before your next interview. Have a good week and keep practicing.